This is the tutorial for Chapter 6, Section 6, titled Systems of Linear Inequalities, day number 1. So the first problem asks us to determine whether the ordered pair is a solution of the given system. So all I'm going to do is just take this x value, which is 0, and the y value, which is 1, and substitute it into the two inequalities. So I've got 1 minus 0 is greater than or equal to 3 times 1, and I do that work, and it shows that 1 is greater than or equal to 3. And this is false. So since I've got 1 that's false, then that tells me that 0, 1 is not a solution of the system. And so the system is both inequalities. But once I find out it does not work with 1, I know it's not a solution of the system. So even if it worked for this one, it wouldn't matter because it has to work for both. So let's try this next one. I substitute the point in for x and y, so it show 2 times by negative 2 plus 3 times by 3 is greater than 2. So I do some work. I got negative 4 plus 9 is greater than 2. And it shows 5 is greater than 2. And this is true, but I still need to try the next one. So I go ahead and substitute there. So 3 times by negative 2 plus 5 times by 3, and that needs to be greater than 1. And so I do some more work there, and that shows negative 6 plus 15 is greater than 1. And this makes 9 is greater than 1, which is another true statement. So since I have both that are true, that tells me that negative 2 comma 3 is a solution of the system. So let's take a look at the last one here, and this one shows 1 and 4. So I go ahead and substitute in, so I have 2 times by 1 plus 4 is greater than 3. So I do some work there, and I've got 2 plus 4 makes 6, and 6 is greater than 3, so this is a true statement. So far so good, but we got to try the next one. So negative 3 times by 1 minus 4 needs to be less than or equal to 5. So I do some work there, and negative 3 minus 4 is less than or equal to 5, or at least it hopefully is. And when we go ahead and finish off the work there, it makes negative 7, yes, and it truly is less than or equal to 5. So we have another true statement. So since both are true, we say that 1 comma 4 is a solution of the system. So the next type of problem that we're going to end up experiencing is actually finding the solutions of the system. So let's take a look at some examples here. And so this one says solve each system of inequalities by graphing. So when we do that, we have some equations that we can do one of two things. Either get y by itself, and that's what I'm going to do here. I'm going to subtract the 3x from both sides, and that's going to make negative 3x plus 1. So I subtracted that from the other side. I took it away from this side here and brought it to the other, and that's why it's a minus 3x here. And so I'll go ahead and graph that inequality, and so I go up one space and then use the slope down 3 over 1, and I have some points there. I can also go up 3 over 1, and then I draw the line. Be really careful about the type of line I'm using. In this case, a solid line to represent that the solutions of the line equal as well, because it has that line underneath. Now I look to see which way I shade. It shows y is less. Less means down. It means smaller values. So all I do is I put some arrows in the direction that I would shade on both sides of the line. Now I move on to the next line, and that one says x minus y is less than or equal to 3. So I'll subtract the x from both sides, and that leaves me with a negative y is less than or equal to 3, and then minus the x, and then I'm going to divide by negative 1. And so that's going to switch that inequality sign around, so it becomes a positive x and a negative 3. So I go down to negative 3 on the y-axis and use the slope. It's a 1-to-1 slope, and so I go ahead and plot some points. So that allows me to draw a nice line. I draw a solid line once more because it does equal. And now I look to see which way I shade. The shading says y is now greater. So greater means you shade above the line. So the whole idea is to look to see where the solution, the two lines agree. And they agree in this region here, above the blue line and below the black line. And so the region that I would end up shading would be right in here. This is where all the solutions would end up being. So anything in this region would give us a true solution for both inequalities. So let's take a look at the next type of problem. So here, I have a problem in which I can solve for y. I can subtract that 5x from both sides. So still have that negative y or negative sign in front of the y, which I need to get rid of. And so I'm going to divide or multiply by a -1. So that, again, changes that inequality sign around. So I have y is greater than or equal to 5x minus 1. So I start one space down using the slope that shows to go up 5 spaces, 1, 2, 3, 4, 5, and over 1. Or I could go down 5 spaces, and over 1 would put me just below the line. Another solid line here. So these are all solid lines, it looks like, as I look at the problems. So again, you always watch those inequality signs. It's only solid because we have that line underneath. This shows y is greater than, so greater means above this line. And so on this next one, I'm going to go ahead and subtract the x from both sides again. So I've got 3x, or 3y. 3y is less than or equal to negative x minus 2. So I go ahead and divide by 3. And when I do that, I've got this. I've got y is less than or equal to negative 1/3 x, and then minus 2/3. So when I go ahead and graph this, I'll start with at the y-intercept of negative 2/3, so that's going to end up being down about right here. And then I'm going to go up or down 1 space and over 3. 1, 2, 3 to the right, because it's a negative slope. I can also go the other direction, up 1 and over 3 to the right. So it's 1, 2, 3. And then I can draw the line. Another solid line. And now I'll figure the shading. The shading is y is less. Less means below. So below the line is going to put me off in this direction. So again, I did not switch the sign this time because I divided by a positive. So the region I would end up shading would be down in here, more towards that third quadrant. So let's modify one of these equations just to change the type of line that I'm going to draw with one of them. Let's just call that a less than rather than a greater than. We'll keep the other one as greater than or equal to, though. So I'll start with that first line. And on this one, how about we do a different method? Let's use xy intercepts this time. So 4x is less than or equal to 1. 3y is less than or equal to 1. So I end up with x is less than or equal to 1/4, and y is less than or equal to 1/3. So when you have numbers like this, they're really close. So like you got to only go 1/4 of a space over and 1/3 of a space down. So it's going to be like this. But you get an idea about what that line looks like. So it's going to be another solid line, and it's going to follow through those points. Again, you can see how difficult it is to draw the line when the points are so close. But you get a general idea about what it looks like. And so another solid line, this time I have x is less than, so I would shade off to the left. Or I could use the y value. Y is less than as well. And so that would tell me to go down. So something appears to be incorrect about this. So again, I see that something's wrong because you see I would end up having to shade below, and that can't be. So I ended up doing something incorrect. So I got to go back and try to figure out what's wrong with this. So I'm going to start by erasing my line, and let's take a look at the points I did. I did x at 1/4, but notice I did y at negative 1/3. I put it down in here, and it should have been in this region here. And so you see I knew I did something wrong because the inequality signs did not match for the direction I should have been shading. So it's kind of a nice feature. And I can go ahead and draw the line. This time I'll go ahead and draw it, and it shows x is less. Okay, so less means to the left, that's right, and y is less as well, so that means shade down. So you see how I had the line going the other way before, and less meant left, y meant down, and it was not in the same region. And so it should be below the line either way. So let's go ahead and take a look at the next one. I'll use that xy intercept method once more. 2x is less than 2, so x is going to be less than 1. And then I have negative y is less than 2. So I multiply by that negative, and that's going to switch that inequality sign and make that a negative 2. So let's go ahead and plot those points. So I go over 1 space to the right and down 2 spaces. And put those dots there and then draw the line. So this is going to be a dash line. I made that this time to make something a little different since all of the others were solids. And I read off the inequalities. X is less. Less means left. So I shade off in this direction. Or I could read the y. Y is greater. And so I know I've done something right when I have the inequality signs agreeing like they do here. So I look to see which direction to shade, and it looks like it's right in this region. That is it. So just off, kind of above the blue line, below the black, kind of in the second and third quadrants mainly. So those are the types of problems that you're going to end up seeing on tonight's assignment. Good luck.